when water isn't evenly distributed around a country, then we have to figure out ways that we're going to transfer the water. And so we look at things like we talked about before, how some communities will truck water. We have the Central Arizona Project now that will bring water from the Colorado River to us. Um, so it's definitely made the Phoenix area more productive. We do have lots of farms and things like that around here that we wouldn't have if it weren't for that water that's being brought into the area. We also wouldn't have the population size that we do if we hadn't brought the water into the area, which is kind of a good news, bad news sort of thing. So I said that if there's water shortages, another thing that can happen is the depletion of lakes and seas. And so the Aral Sea is an example of when this can happen. So the Aral Sea is actually a freshwater lake, not quite the size of like the Great Lakes, but you can see how over time um, the water in the lake has been depleted. So in the areas up north of the sea, which is where the water is flowing, you kind of see the drainages coming here. The water comes in from that direction, and then this greener area down here is the outflow. So these are like freshwater marshes and things like that where the water flows out. And north of here, there was a lot of agricultural areas, and so they started to divert the water in the waterways that were coming down into the Aral Sea for use in agriculture. And as a result, over time, um, water wasn't coming into the Aral Sea anymore. And even if it's a freshwater lake, you still have dissolved solids that are in there, which is what salinity is. So the salt content became like raised up a lot, and so you ended up with this very what's called brackish water, which is very saltwatery areas. And you can see where the things that used to live in here don't live in here anymore. You can see that the vegetation that used to grow around the edges is no longer there. So it's had a significant impact on the biodiversity of the area as that water level depleted. Another way to move water around would be, so this one, go back to Aral Sea for just a second. So this was a consequence of transferring that water, of taking water from a river source and moving it to another area for another use. So there are consequences for those actions, and one of those consequences was this Aral Sea disaster. Another way that we can move water from place to place is through desalination, which is basically what they do is they distill the water. So you can buy distilled water in the grocery store, up, um, it evaporates, and then it leaves all of the warm particles behind, and then it'll condense in a condenser or a cooler area, and it'll drip back down. It takes a lot of energy in order to make salt water into fresh water. So using the form of distillation. Reverse osmosis, some of you may have RO in your house, and basically what it's doing is it's pushing the water through a filter that then takes all of the particles out of it. So if you have RO in your house, you're probably not taking salt out of it. You might be taking things like calcium out of your water, but it's the same basic principle. Once again, it still requires a lot of energy in order to do that. So another way of getting more water into an area is towing icebergs. Um, this is one of those kind of less realistic options. If you're towing an iceberg, obviously, as you move it from a really cold area to a warmer area, you're going to have a lot of melting that occurs. In some cases, they actually like put it into ships. Um, Also, once again, really energy intensive and labor intensive for very little payout. So, but one of our best options for increasing our water supplies is by water conservation. So, not necessarily saying that we're adding water to our supplies, but because once again, it's that if I don't spend my money now, I have the money later. If I don't use my water now, then I'll have the water later. So, if we cut down the amount of waste of water through things like evaporation or leaks, think about like toilets in your house if they run constantly, or if you have leaky faucets or something like that, then that's a way that we can increase our water supplies because we're not wasting. With irrigation, we can use better irrigation methods. So we're going to look at the different kinds of irrigation methods and show like which ones are more effective than others. So in a lot of areas, and you'll see this around in Phoenix especially, you'll see just these open irrigation ditches. And so it's a flood method, usually either along one of these rows or along the top. You'll have an area where they just basically open the valve and the water comes down. It's gravity fed, so there's a slight pitch, so it goes slightly slips downhill. But all this area here loses water to evaporation. Um, so it's not very efficient. And in this area, it's groundwater. So here where it says it might come from an aqueduct system or a nearby river, ours is usually pumping groundwater, or it's coming from the Central Arizona Project Canal. Drip irrigation is extremely efficient. It's probably the most efficient, but it's only practical under certain circumstances. You can see they're not showing drip irrigation in things like row crops or something like that. They're showing it in trees. These are going to stay for a long period of time in one spot, but they're not usually going to drive heavy machinery around because you can't drive over the top of the drip irrigation. What it's doing is that it's bringing the water directly to the roots, either right at the ground level, and the only place the holes are on the bottom side, or it's right below ground level. We use, you might use this around your house with soaker hoses, that kind of thing. Highly more efficient because you're not spraying water up into the air where we lose evaporation, and you're also not having these areas of water. Central pivot is what gets used the most in our irrigation of our crops and things like that now. That's why most of your fields that you see are round anymore. Usually there's a well that's dug in the center, and this is where the pivot is. There's usually a tire on the other side of it, and it's set to go at a certain time, and so it'll slowly go around and it'll spray the water down. You have some loss to evaporation because it's still getting sprayed, but it's way better than when they used to put you see like playgrounds or something like that, or parks where they just have sprinklers in the corner and they shoot long sprays of water. There's a lot of waste that occurs in there. There's a lot of evaporation, not a lot of it gets to the ground, as opposed to this where it's like spraying it directly on the ground, so it's much more efficient. So when we look at reducing our irrigation wastewater, really I know it says we can line the canals. Basically, that's not so much waste as water going back down into the aquifer. But if we can remove canals as much as possible, that would actually reduce our water waste. When they want to level the fields, the reason that they want to level them is so that the water actually slopes down and it doesn't stop and puddle, and then it requires more water to get to the the next one, like with irrigation, this can be in homes or in agriculture, and that is that you water at night to reduce the amount of evaporation. It's actually better for the plants. They're under less stress during the nighttime anyhow, but you don't have that, especially here in the summertime. Monitoring the soil moisture so that you're only watering when necessary, especially those plants that you might deep water. You can use, like if they're supposed to be wet down to 2 feet, use a piece of rebar or plastic or something like that that you can push down into the dirt that has a marker for 2 feet. If it's already wet that far down, then you don't need to water at that point in time. When we look at polyculture and the organic farming, a lot of that is increasing the biomass in the soil, which holds on to more water, so you don't need to water as much. And then it's what do we choose? What do we choose to grow? Not growing those thirsty crops, and having those. Talked a little bit about genetically modifying crops, and one way that they GM crops was to make them more water, so they wouldn't need as much water. So using those kind of crops is much more helpful. Some of the urban wastewater, so it's the gray water where we can use to water areas with. I know this happens in a lot of parks and areas around already. The water is safe. It's not necessarily what you would want to drink, but it's safe for crops.